SV Math Teach back one more time. Last video in section 2 on functions, equations, and graphs, and this time on two-variable inequalities. When you're graphing two-variable inequalities, key idea here is that you have boundary lines, and boundary lines can only be one of two things. They can either be solid lines, and you'll see them solid if they are greater than or equal to or less than or equal to, or they could be dashed lines, which means that's a boundary, but the stuff on the line isn't actually part of your solution. And that would be greater than or less than, or you could probably argue not equal. Although the not equal one is not really a very common version of what we're doing, so I'm going to take that off. And if you're not sure what I mean by boundary line, let's imagine a very simple inequality. X plus y is greater than 1. What we mean is, let's imagine some ordered pairs that would work here, right? 1, 1 would be a solution. 1, 2 would be a solution. -3, 5 would be a solution. If you add them together, they give you a number greater than 1. If we were to graph this, 1, 1 is about here, 1, 2 is about here, -3, 5 is going to be about here. We're kind of estimating. I believe we're going to have a number that's going to be something like at a very rough graph, I'm going to have a series of dots that are solutions, right? Let's do another solution, 10, 10. 10, 10's out here somewhere. Or 4, 4. 4, 4 is over here somewhere. Notice how all of the dots are above or to the right of that dashed line. So that dashed line is the boundary between the not answers and between the answers, right? Everything to the right of it or above it is going to be a solution. And the way we graph these, you typically just shade these in. And on Notability, I just grab my highlighter tool and kind of shade those in. And that's that. I have one example, and we're all done. So it says graph y is less than the opposite of the absolute value of x minus 3. Now, I'm going to use a couple of the ideas from before. I'm going to nail down my vertex. My vertex is, let's see, that says -3, so I remember it's opposite, so 3. And I don't see any up or down movements, so 0. So 3, 0 is right here. There's my vertex. I recognize that I do not have any multiplier that will stretch or compress, but I do have this guy. That's going to flip it over. So instead of going in V shape like I've done before, I'm going to go V shape but upside down. So when I draw this, I'm going to be careful to hit, like I'm trying to hit this point, and this point, for example. So I'm going to draw this line as carefully as I can, down and down, right? Now, if you've done like I've done, sometimes you draw the lines and then you go back and you think about, well, what kind of boundary line should it be? If it's solid, leave it alone. In this example, I'm going to look at my inequality. This should not be solid. This should be dashed. So I got to be honest, I'm going to go ahead and do a partial eraser mark. If you have a pencil or eraser, you can just do this. I'm just going to make some dashes in here. Seems like an easy way to do it on the iPad. You could do something similar, of course, if you're paper and pencil, you could just make a dashed line. And now all that really happens is, do we shade all of this stuff? Let's make my shading nice and big. Should I be shading all of this stuff up here as examples of solutions, or are the solutions all down here? One of the two of those are correct. So the easiest way to do this is, the most accurate way to do it, easy is relative to you, but the most accurate way to do it is pick a test point and try it. This will always work. And a test point that's not on your line and is not your vertex is probably the best way to go. In this one, the test point of 0, 0 looks like it's great. We're basically testing whether that thing is true or false. So I'm going to take my inequality and I'm going to substitute 0, 0 in both x and y. And then I simply evaluate. I'm just trying to determine whether this thing is true or is it false. So 0 is less than negative, let's see, 0 minus -3 is -3. The absolute value of -3 is 3. And 0 is less than -3. This is false. Because that's simply not a true statement, right? 0 isn't smaller than -3. So that means that this 0, 0 is false. That means that it does not work. And that also means that every other point up here, no matter what we would have picked, any other point that would have been on the same side of our graph as our test point would have all come out to be false. That also means that every point on the inside or the opposite, these would all be true. So let's highlight the true stuff. Come in here with my highlighter tool. I should probably be a little bit neater, but I guess you get the idea, right? So that is the idea, and that is the last item for graphing inequalities.